Okay, welcome. So this is lecture 9 of Electronics 1. I can proudly say that this will be the last lecture for this YouTube series for Electronics 1. So we have 9 lectures total. Today we're going to look at CMOS. So that's basically it, guys. That's the full class. I try to help as much as I can. Now, quick little disclaimer before I move forward. All these videos that I've been producing, recording, and publishing for you guys, all these are my personal work. So it's not in affiliation with any organization, and I'm not mandated by any organization to make these videos. This is these videos come out of my own goodwill to help students benefit from it and learn electronics and perform better on exam. This is my initiative, my personal initiative, my personal work. Everything that I put on here is my personal work that I created on my own. So with that being said, when I'm publishing videos on my YouTube channel, a lot of my viewers already know. They know me personally. They're my friends. They understand who I am. They understand my sense of humor. They understand They understand that I'm a joking person. I'm very humorous. I like to keep things lighthearted. I don't like to get too serious about things, and especially this being my personal channel. Um, this was my intention, and I want to be very, very, how do I say this? I want to be very joking about it. I want to be very lighthearted about it, and I want to be very casual. So, with that being said, there was a joke in my previous video that was, I think, it triggered some viewers. I apologize for that if you found that a little bit offensive. There was no ill feelings about it, so I just apologize and move forward with it. So, in the future, if anyone has any complaints, queries, concerns about what I'm producing, contact me directly. Okay, that would be much appreciated. So with that being said, let's go into CMOS circuits. So with CMOS inverter, you probably went to class and you've seen a whole pile of derivation calculating time and currents and all of that thing. I will just come up and then tell you that's all like bakwas, and you don't have to, worry about those too much for the final exam because you have a whole class on complementary MOSFET devices. So CMOS just means complementary MOSFETs. You're gonna have a whole class on that. That's called VLSI design. That's if you choose to go towards that path of electrical engineering. Okay. So again, this is probably going to be worth like 10, 15 marks on your final exam. And there is no point in going and understanding every single thing. They obviously go through one time, two times so you understand what it's all about. But you don't have to memorize the proofs. In my opinion, I don't think it's that important. You don't have to, worry too much about it. Electronics 1 is an analog electronics course where you're learning how to calculate gain and all that stuff. So that's a big bulk. If you know how to calculate gain, overall gain, current gain, input impedance, output impedance, you're gonna pass the class. I promise you're gonna pass the class, assuming you know how to do those perfectly. So with CMOS right here, I have what we call kind of a cheat sheet situation, and what I want you to do is I want you to listen to what I tell you, and then kind of memorize the thing that I tell you to memorize, and then go on the final exam and kind of like copy paste the same process because there's not much they could ask you about CMOS, right? They're not going to ask you derivations. It takes too long. It's not a point of the course, okay? So CMOS complementary MOSFET. If you look at the circuit here, you have an input and then you have an output, basic, and then you have a PMOS and an NMOS, right? Complementary MOSFET. So you have uh, PMOS, so for a P-type MOSFET, and then an NMOS for an N-type MOSFET. So this is what we got going on. And essentially, this thing is just a NOT gate and digital logic circuit. So you can kind of imagine everything in box in a NOT gate. This is what a NOT gate is, okay? So this is what we got going on. Now, within that CMOS, to your professor, when your professor went through the class with you, your professor probably derived a lot of things. There was a lot of facts and a lot of assumptions that he made. So these are the assumptions right here that I wrote it down, and these are the facts. Do you need to have them memorized? Probably not. Is it helpful to know about it? Yes. So I won't go about all of these assumptions and all of these facts. Basically, it just means that the threshold voltage for the NMOS is equal to the threshold voltage that's given to you in the question. The threshold voltage for the PMOS is given to the threshold voltage given to you in the question with a negative sign in front. These MOS characteristics for the NMOS are equivalent to the same characteristics for the PMOS. Same thing here for the lambdas. And then VT is much less than VDD. So your threshold voltage is going to be much less than VDD, which is the DC voltage that you're going to feed your PMOS and your NMOS. So basically your CMOS circuit. So that's number one. Number two are these facts right here. These facts, you can kind of look at the circuit right here in blue. I just kind of drawn them right here. So we have ID1 equal ID2. That's fact number 5. Vin equal VGS1. That's fact number 1. And then VGS2 is Vin plus VDD is clear. V out is VDS1, and then V out is also VDS2 plus VDD. So these are just the facts. These are the assumptions. Not a big deal so far. Okay, when we look at the graph, that's when stuff starts to become a little bit important. In this graph right here, you're gonna notice. I want you to memorize this graph, right? So draw it multiple times, memorize everything that's on here. Okay. So what you got going on here is you got this graph, okay, and then you have the output versus the input. So you will realize when the input is very low, close to zero, the output is very high. Okay. And when their input is very high, the output is very low. That's the nature of the complementary MOSFET. That's the nature of the NOT gate, right? When you have a zero logic signal, you're gonna have a one output. When you have a one input, you're gonna have a zero output. So that's basically what it is. Okay. So that's the nature of the input output characteristics of the CMOS. Okay. And if you look over here, we have a region right here of uncertainty. Okay. And this region of uncertainty is between two voltage values of the output. So if I extrapolate this over here and I extrapolate this over here, we have these two values: VDD over 2 plus V threshold, VDD over 2 minus V threshold. Now, V threshold and VDD over 2 will be given to you in the question, most definitely. I'm kind of very sure about it. And then if you look at the input line right here, we have VT, VDD over 2, VDD minus VT, and VDD. Where do these numbers come from? Derivation in the class. Do we care about them? No. So these are what we got going on, okay? At the same time, this is your V output low, and then this is your I actually label everything here, okay? So not to worry about it. So you can just zoom out of the video, go watch it, and you'll see what everything means right here. If you look over here, it's just NMH and an NML. These are those voltage differences. I don't remember having ever used these in when I took that class, honestly. Same with these two. I don't ever remember, I don't ever recall having used them even once for an assignment, even for a lab, and it didn't show up on the final exam. So I wouldn't worry about this about, I wouldn't worry too much about it. So look at the CMOS inverter right here. Okay. Um, Before we do that, let's go back to the graph. And like I said, when you're looking at this graph, you're gonna have 5 regions between voltage ranges. Okay, so this is region number 1 in this range, region number 2 in this range, region number 3 is a very small range, right? Where you have this line of uncertainty. That's region number 3. Region number 4 is gonna be this range, and region number 5 is gonna be this range right here. Okay. And if you look over here, I kind of very already labeled these regions right here. Now you can see that these regions of voltages are given. That's your input, by the way. Okay, so these regions are defined by your input. So you can kind of see that these voltage ranges, they're between values that are variables. But these variables, like I've said, they will be given to you in the problem. All right, when you're solving it, all right, it's gonna be known what VDD and VT are. So with that being said, you're gonna know what these values are. Okay, what these values are. So you're gonna know what VT is, and the moment you know what VT is, you're gonna know what this range is in numbers. Okay, that's gonna be clear as day where those ranges are located and what you're working with essentially. So once you have VDD and VT, this is gonna convert into a range of numbers, maybe 0, 1, 1, 2. I don't know, whatever the numbers are. Okay. So keep that at the back of your head and memorize this as well. So the first thing you want to memorize this graph. Second thing you want to memorize is you want to memorize this thing, all right, associated with the ranges. Remember that these ranges are associated with the input voltage. So that's another thing. And now what can happen in your final exam is that you're going to be given a question on a complementary MOSFET, and you're going to be told between this voltage and this voltage, which MOSFET is in which mode and which MOSFET is in which mode, okay? And the goal of that exam question is very tricky, because if you want to do it from scratch, you would have to derive everything by yourself. Now, you don't want to do that, right? It's going to take too much time. And honestly, how do you derive all of that in the final exam? It's going to take you too much time, okay? But that's the whole point. They're trying to get you to trip at the end of the day. So what you want to do is you want to have these memorized so you can go right off the get-go, pop, 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 pop. It's going to be very nice. So if you look over here, I have this regions in a table, right? You probably have these in your lecture notes too, but these are the regions 1, 2, 3, 4, 5. These regions correspond to these values right here. And then it tells you when you're in region 1, this MOSFET, the NMOS is in cutoff and the PMOS is in triode. When you're in region 2, you have NMOS in saturation, PMOS in triode. Region number 3, NMOS in saturation, PMOS in triode. And region number 4, NMOS in triode, PMOS saturation. Region number 5, NMOS in triode, PMOS cutoff. Okay, so that means when you're in this range, you're working with this mode. Okay, when you're in this range, you're working in this mode. Okay, so your problem is going to give you two voltages, going to give you V threshold and VDD maybe, and then from there you're going to calculate your ranges, and then it's going to have a table. It's going to tell you when the input voltage is 2, what is the modes of your transistor. So you're just going to have to fill in the blanks and keep on going. You're going to have a huge table like that, multiple input voltages. You calculate your ranges. You look at the voltage. Which range does it fit in? Oh, it's fit in this one. What range is this one? Oh, this is region number 2. Region number 2, I remember my chart. Oh, this one is cut off. This one is in saturation. So then I go back and I pick my modes of the transistor. Nice and simple. So if you look over here, we're gonna try. I'm just gonna give you an example of what's gonna be like. Okay, so memorize this, and memorize this. Okay, it's going to give you a value for the inputs. Maybe v input equal 2. VDD is known. VT is known, right? You use these values, you calculate your ranges. And then, for example, it tells you V equal 2 volts. You choose which one which category it fits in. Let's say it fits in this one. So category number 5. And then you go to number 5, and then you say that NMOS is in triode and PMOS is in cutoff, okay? Now, let's say you had another value, V in equals 7.5. What you're going to do, you're going to take 7.5, you're going to see what range does it fit in. Maybe it fits in range number 2. So then you go to 2 and you're going to say NMOS is in saturation and PMOS is in triode. So this is how you solve the problem. This is the final lecture. This is basically what it is. So don't overthink the MOSFET. You're not going to see the MOSFET. Don't overthink the MOSFET. I'm talking a stupid way right now. Don't overthink the CMOS. You're not going to see CMOS in electronics too. Don't worry about it. That's a whole course in VLSI design. And if you're of sane mind, you would never have to take that class, because I took that class and I got tripped over hard. I thought I was good. Turns out I wasn't. So remember what I told you, memorize the thing that I told you, and then that's basically it. That's the end of the series. Honestly, when I started the series, I didn't expect it to get this far, because every single video that I posted got over like 100 views. So that's a huge achievement for me, because it means that pretty much everyone taking that course have watched my videos, or they know about me, and that's something I can proud I can be very proud of. With that being said, watch out for Cookies and Crown upcoming. I'm the one taking it, so if you want to see me in person, attend the session, bring a huge crowd. Let's try to break attendance records, and it's gonna be a fun time. Okay, it's gonna be a very fun time. It's gonna be a fun lecture, and we're maybe gonna laugh out hard together. So with that being said, if you want to see more content from an unconventional small YouTuber, hit that subscribe button, and peace until next time.